Hello everyone, good morning, afternoon or evening as your time as you wish. Today we gonna simulate a real lead rubber bearing produced by DIS company, which is a dynamic isolation system. Let's take this isolator, 400 millimeters of the diameter. Here we have the thickness and the H is the total height of the isolator. Our section 25 for load plate millimeter, 3 millimeters for steel and 8 millimeters for rubber. We have 14 layers. Lead core, the diameter is 100 and we don't have fixed plate. Look here, only load plate. It doesn't even matter. It will not change the results. Sometimes you have, sometimes you don't have fixed plate. So let's get started. Standard start part. First one, let's take the steel, deformable and extrusion. Continue. Let's draw our section 200, the radius, comma 0. Finish, done. The thickness is the 3 millimeter and for rubber is same radius but different thickness. So here the thickness is 8 millimeters, done. 8, okay. Let's do the load plate. I will try now the revolution to see the difference between revolution and extrusion. Now we have to use rectangle to rotate the shape. Radius is, let's make it bigger than 200, so let's take 230, comma, thickness is 25 millimeter for load plate. Okay, done. Rotation, full rotation, 30, 36, 0, okay. Now let's take the lead. Extrusion. Okay, continue. The radius now is 50 only, so 50 comma 0. Done. The thickness now is the height of the lead core. So our section, let's see our section. It's 151 because 25 up, 25 down because of load plate. So 151 millimeter. Okay. Okay, it's looking great. Next step to properties. We have rubber, steel, and lead. So let's start with lead. Okay, lead, elastic and plastic. Elastic. I will take general properties. So let's take 14,000 and 0.42, around 40. Plastic, let's take 10 megapascal, 0, 10, 6. Okay. Now let's take rubber. Here we have to use elastic, hyper elastic I will use Mooney. Coefficients. The equation of Mooney is C10 plus C01 brackets 2, so I will take 0.5 megapascal, so 24 0.01, and no buckling, I will take it 0, D is 0, no buckling. Here we can see the range of G for this company, they are producing between 0.38 and 0.7 megapascal. So let's add the hysteresis parameters. 1110. After finish the job, you have to come back to these parameters and change it to make your hysteric loop properly. Okay. Yes, actually, the appropriate way to use test data, but we don't have test data, so we use the hysteresis parameters. Let's now do the steel. Elastic. Obviously 200 000 comma 3 plastic. I will take 250 megapascal, so yeah, 1. Okay, finish. Okay, next to assembly. Yeah, before we have to assign, it's better. We have steel and lead and rubber, so let's do it. Steel, rubber, and lead. Yeah, we have to assign now. Yes, let's start with lead. Assign. Select. Done. Lead. Okay. Next, load plate. It's steel. Select steel. Dismiss. Next to rubber. Rubber. Create. Select rubber. Last one, steel. Yes, we can check here from section. Yes, it's lead, so very good. It's better to do the partitions because we have a circle section. It's better to use partitions. That will make our job easier. So, and it will make the mesh better and symmetric. Yes, create. Yes, it's looking great now. Yeah. Next to rubber. We can use 3 points or edge. It will be faster, so just 2 points, two selections. Boundary and point only. Load plate, same thing. Here, after we doing the partition for load plate, it will make our job easier to find the midpoint, center point. So for lid, let's take 3 points, 2 same direction and 1 linear and 1. Yes, done. Whatever. Yeah. Okay, done. Now let's go to next to assembly. Select all. I need it. Yes, this is better. Look, all of them is we have to rotate them, but the load plate we don't, because it was a revolution, but this was extrusion, so we have to rotate them. I will bring this one to 0 0. Yes. Now let's rotate both of them 0 0 and just make it here 190. Yes, we have to make the surface to surface, so the bottom of the rubber will bring to this surface. So flip, okay, 0. I don't need any displacement, any gap between of them. So also here we need to make the steel, yeah, up on the rubber directly 0. I don't need any displacement or gap. Now I will bring it to the load plate. Select just only the boundary. Okay, also for steel shims. Okay, it doesn't even matter if it's same arc or not, just do it. Now we have to do what? To cut the section because there are overlapping. So cut, suppress. Let's start with the steel. Steel. Let's make zoom. Steel. Okay. We have first to resume the lid to make it back, and we don't need the steel anymore, so let's delete all of these red X. We have, yes, this is still not rubber, so delete. Yes, I don't need these anymore. Delete. Okay, yes. Now for rubber, cut, rubber, continue. Oh, we have rubber already, so we have to rename or delete. Come back, parts. rename, 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 rename. Still, this is a still. I will make it a triple E because I have still already. Yeah. Now let's do it. Rub. Okay. Select the rubber. Okay. Resume the lid. Delete this one. I don't need it anymore. Also the positions. Okay, now we have 14. Yes, it's looking great. We have 14 layers. Let's check if something is wrong or not. I think it's properly. Yeah. So let's duplicate. Before that, I will check. Yes, let's check our points. Yes, 151. Yes, that's great. And let's take this one. Should be, yes, 200, 0, because this is 0 level. So, okay. Let's take the upper one. Should be both steel and rubber, so it's 11. 8 for rubber and 3 for steel. So now I will do the to make it double. 14 layers. So let's do our array. I need steel and rubber. Select OK. Okay. I need only one direction, so look for the gap. It's really fine. So I need only one direction. Yes. We have 14. Yes. One more. Look, we have to delete last steel plate because we have only 13 steel plates. So delete. Make it zoom. Yeah. Let's check. It's for free. Let's check from what? Let's do the load plate first. Yeah. Yes, plus 25 for the thickness. So it will be 176. Yeah, let's check. Yeah. Points. Should be 176. Okay, that's great. Done. Okay, let's check if there is any overlapping or something. I think it's looking great. Next to what step do our we have 2 steps. First one for vertical load. We have to make it on. Yes. For vertical it's only 1 second, it's enough. Minimum, let's take it 0.5. You can minimize the minimum. Okay. Next one, let's take the cyclic load. No, we needed to do what? 4 or 8. Let's take it 8 seconds for 2 cyclic loop. Each step 1 second, so it's better to increase this one because sometimes take a lot of increasement. We need to minimize this one to 0 point around 1 or 2. Here let's take it 0.5, and it's better to minimize this one to 7 or 6. Yes, okay, dismiss. Let's define our output. I don't need any contact, I don't need it. So stress, yes, I need stress, strain, displacement and forces. Okay. Actually, there is time points we can use it to fix the results, to fix the rows of results in specific time. So I don't need like results for each increasement. Delete this row. Yes, delete. This is very useful if you are doing your job many times. So it's better to use time points to fix the results in specific rows. Let's do the interaction. Yes. Look here, the midpoint, it's very easy to select the midpoint. Done. Let's find the surfaces. I don't need any displacement between surface to surface, so I need only the touch, who is touching. Yes, all of them now is ready. Let's take it, do it time constraint. Okay. Okay. Let's check surfaces. They are coming. Okay, done. This is the easiest way. So now to load. For load, the maximum is 900 kilonewtons. So it's better to make it pressure. So pressure, it's depending on the area of load plate. So it will be around 900, around 5. Let's take pressure. Step 1, be careful. Select the surface. Keep pressing shift to select all of them. It will be around 5 megapascal, 5.4. Let's do what? The boundary condition. You will start with the load plate, the top one. Continue. Select which one? This one? No, this one? Yes. Okay. Continue. We have only U2, so I don't need any of these deformations. I don't know the vertical, so only U2 is unknown. I will edit in step 2 because we have horizontal displacement, and it is amplitude because we have frequency right to left, left to right. So let's start 0 0 1 1 1 1. Actually, let's take it from Excel. I will copy paste, it will be faster. Yeah, copy paste 0 minus 1 0 minus 1 for all. Delete this one, I don't need it. Only 8 seconds. So this for step 2. Okay. Amplitude. Yeah, okay. Now for the bottom load plate, initial, we needed to fix. Yes, full fixed. So all of these, check. Okay. Now actually there is another way, easiest. Let's see, from symmetry. So select the set. Look, we have standards, so you can choose anyone, but I have already do it, so no issue. Anyway, next step, let's go to mesh. I think, yes, mesh part, each part 14. Let's try if it's small, it will take a lot of time, so I will make it bigger. I don't need appropriate results now. Let's try first the lid. It's good. Okay. Assign, we didn't assign. Yeah. And we didn't assign the steel. Yes, this one. Assign. Load plate. It's good for load plate, no problem. Assign. Oh, this one is hexed, and it will take a lot of time in the job, so I will change it to another kind. So select all. Let's take it wedged or tet. It will be triangulars. So apply. Okay. Yeah, this one will be faster for the job. So rubber. The rubber, let's take 25. In the rubber we have to what? We have to select all and make it hybrid. uh, if you didn't select this one, it will not the job will not start. And also it should be hex. Now it's looking great. Zoom. I think it's fine. Now let's go to job. Yes, job. Create a job. Not 700. It was 400. Sorry. 400 and 100 for lead. So memory you can increase it. And the most important thing is the processor, so let's make it full. Let's check data before we submit. Complete, nothing, so we are ready to submit. Yeah, one thing we didn't do the what. Yeah, here the time we didn't select it. Anyway, you can use it here, the time period, or add from here, whatever, but let's keep it increment, so you have many choices. No, but the issue is we didn't add the U1. Yes, we have to make it. Let's do it 260 millimeter and do the job again. Sorry. Yeah, I have killed the job. I will submit it again. Okay. You can use monitor to check your results, how they are coming. Yeah, warnings, it's not matter, it doesn't even matter whatever you have. The issue is with errors. Yeah. Let's kill the job because it will take a lot of time. I will stop in the middle after 2 seconds. I just want to show you the results. Wait, yes, now it's killed. Yes, killed. Results. Oh, how much it's nice. Looks great. You can do a section. Yes, stress, miss stress or whatever. The LE, yes, look here, the SMS is only in the steel shims. Yeah, and LE is the s- the strain. So 1 2 is the shear strain. This is the shear strain, and you can take XYZ section, or you can make it both. Allow for multi. Yeah, and you can make it up down as you want for appropriate level. Okay. Stop. Let's do the XY data to do our history loop. Yeah, ODB. Continue. We need the unique nodal, so I need only horizontal displacement and the horizontal force. So look here, it's really easy to find the midpoint, because we did the partitions. Yeah, let's draw, combine, double click, U1, double click, RF plot. Yeah, there is an issue here, maybe because of the shear strain is very big. The maximum around 0.15, I think. Let's make it bigger. Font, dismiss, and let's show the min and max results. Yeah, we can see it's around 800 kilonewton, the horizontal force, maximum horizontal force. Yeah, we didn't take it full cycle. You can edit the results to export it to the Excel. Yeah, and it will be fixed if you use time points. Yes, thank you for watching. Goodbye, good luck.